Welcome back, everyone. So as previously promised, what we're going to be doing today is we're going to be starting to get set up for the midterm exam, which is coming next week. So let me start by pointing out some things that I've set up on the course website. First of all, there is now a new section on the course website titled Exams. Anytime I give an exam or release any other material related to an exam, you'll find all of those things in this section of the course website. Right, so here's how the midterm exam is going to work. It's going to be a 24-hour take-home exam, and the way it will work is that at 9 a.m. on Wednesday of next week, I will be posting the problems, and you'll see a link to them here in the exam section of the course website. There more than likely will be two problems, each of which asking you to write a program to solve that problem. Right now, the parameters of the exam are that you'll have 24 hours to do the exam. You'll have until 9 a.m. on the following day to send me your work. And of course, this is an open book exam. You're welcome to use the textbook. You're welcome to use any of the materials that I've posted here on the course website to refer to them and even copy codes from various places. That's all perfectly valid for this exam. And the other thing that we'll need to do is, since we're plunking down the exam in the middle of the week next week, we'll have to make a few changes to our normal weekly schedule. One change that I'm going to make is that normally the people who take the lab on Tuesday have until 5 o'clock on Wednesday to turn in their work for the lab. Well, next week I'm going to change that so that everybody taking the Tuesday lab will have until 5 o'clock on Friday to turn in their lab work, which is also the same time that the Thursday lab groups will have to turn in their lab work. Right? So that will make it possible for the Tuesday lab people to comfortably take the exam on Wednesday. Also, because we're going to be doing the exam on Wednesday, there's not going to be a lecture that day. The whole day is just going to be dedicated to you to work on the exam problems. During the exam, if you have questions about anything, you'll be welcome to email me. The only constraint there is because this is an exam, I'm going to be limited in the kinds of questions that I can answer. An example of a question that I can answer is that if you want clarification, if you want some clarification on what a particular problem is asking for, by all means email me and ask me for clarification. But if you need help beyond that, I'm afraid there's very little help that I can give because this is an exam. It's supposed to be your own independent work. And for that reason, I'm going to be very stingy in my normally fairly generous support, helping you find errors and fix them. Okay, now another thing related to the exam is in the exam section of the course website, I've posted a study guide. And the study guide repeats what I just told you here about how the exam is going to be set up. Another detail that's relevant here is which chapters the exam is going to be covering. It's going to be covering chapters 1 through 6. Chapter 6 is the chapter on methods. And since we're going to be stopping with chapter 6, there will be absolutely nothing on the exam having to do with arrays. Arrays are chapter 7, and this exam will have nothing to do with arrays. It's all going to be loops, if statements, methods, those kinds of things we're going to focus on for the exam. All right, now, to help you prepare for the exam, another thing that I've done is I have posted some additional homework problems that if you have time and energy to do this, you're welcome to try these problems. These are all even numbered problems from the textbook because in the author's website, the author actually posts solutions to all of the even numbered problems. So you can work these problems and you can find solutions to them. So if you have extra time and you want extra practice, I've chosen these as good examples of problems to practice on. Then above and beyond that, I've also posted some sample problems. Both of the problems that I've posted here are problems that appeared at one point in the past on a midterm exam in this course. So these problems are quite typical of the kinds of things that you may expect to see on the exam. And for each of the problems, I've posted a statement of the problem, and then I've also posted my solution. So again, if you want to just try practicing doing this, try your hand at solving the problem. And after you've worked on it, if you need to look at my solution is going to be posted here and available for you to see. All right, and I've got 2 sample problems like that posted. Okay, any questions at this point about the setup of the exam and what the exam is going to cover, or any other detail related to the exam?
How long the exam is going to be?
It's a 24-hour exam. I'll be posting the exam at 9 a.m. on Wednesday, and you will have until 9 a.m. on Thursday to turn in your work.
Thank you.
Yeah, the reason I'm giving everybody 24 hours is that you folks are scattered across a huge number of different time zones. And if I were to give like a traditional 70-minute exam during the class period, that would be a real hardship for some of you who are way off in time zones that are 12 hours away. So for that reason, to avoid any time zone problems, I'm simply giving everybody 24 hours to work on the exam. I think that's a fair way to do it. All right, any other questions related to the exam? Okay, now the next thing I want to talk about is we're continuing with what we were doing. All this week we've been talking about arrays. I haven't yet assigned any work on arrays, and since this is Friday and I traditionally assign programming assignments on Friday, I have posted a programming assignment from Chapter 7. This is problem number 23 from the end of Chapter 7, and we're going to follow our usual arrangement. I'm posting it today. It will be due by 5 p.m. on Tuesday of next week. And also next week, the lab will focus on arrays. We're going to start doing some exercises to give you more practice working with arrays. We'll be working with arrays next week and the following week because arrays are a very important topic in programming. We're going to dedicate 2 labs to that. Okay, now for the rest of the time that we have today, what I thought I would do is stop showing you some new material for a while and instead go back and review some of the things that we've gone over. And one thing in particular that I thought would be worthwhile to do would be to give at least a short talk about some common errors that I've seen people make. And I wanted to give you my suggestions for how you can avoid these errors. What's been happening over the last few weeks is I've been helping almost all of you work on your labs and your programming assignments. And after talking to a lot of people over many weeks, certain patterns emerge of what are sort of the most common problems that people run into. So what I thought I would do today is talk about some of those common problems and give you suggestions for avoiding these problems in the first place and dealing with them when these problems actually arise. Right? And so what I've done is I've written up a short set of lecture notes dedicated to this topic. You'll find it under the lecture notes of the course website titled Avoiding Common Errors. So let me now switch over to my set of notes that I wrote on that, and let's talk about some common mistakes that people make during programming and how to avoid them. All right, now let's start with the most basic mistake. The most basic and most simple mistake you can make in a program is some sort of a mistake involving a variable. And specifically, when you are working with variables, there are 3 common things that often go wrong related to variables. The first of these is that any variable that you use in a program has to be declared. And simply forgetting to declare a variable is one of the common mistakes that people make. Second issue is that declaring a variable is not sufficient. You have to do a second step, and that is you have to actually provide that variable with a value by some means. And if you forget to give the variable a value and you then try to use it as part of a calculation, that's going to be flagged as an error. And of course, another common problem that comes up from time to time, this is a fairly trivial problem, is sometimes you'll misspell a variable name. You'll leave off a letter or you'll forget to capitalize a letter. That's another fairly trivial but common error that people make related to variables. Okay, now the story with all 3 of these problems is that NetBeans is going to be very helpful in this regard, because as soon as NetBeans sees you making one of these errors, it's immediately going to put a red underline under the variable involved. And as always, the usual thing to do in NetBeans when you see a red underline is to simply move your mouse pointer over the underlined text, and that will pop up a little error message telling you what NetBeans thinks is wrong. So for example, if you hover over an underlined variable name and you get a message that says cannot find symbol, that's sort of NetBeans' way of telling you that you forgot to declare the variable. You need to, at some point, insert a variable declaration that declares that variable. Another thing that will happen is that if you hover over a red underline and the error message says this variable might not have been initialized, that's a significant clue that you maybe forgot to initialize the variable. So that's a much more helpful error message. And finally, if you hover over a variable and it says cannot find symbol, but it's a variable that you think you're pretty sure you declared, most likely what's happening in that case is you simply misspelled the variable name, and that's something that's fairly quick and easy to catch. All right, so in every case, NetBeans will be very helpful in this regard. All you have to do is just be careful enough to look at the error messages and read them and see what they're telling you. NetBeans is going to be extremely helpful in helping you catch and fix these types of errors. Now, here's a piece of advice I will give you to help you even avoid these errors in the first place. And that is, of course, whenever you set up a variable, you have to declare it and you have to give it a value. One of my recommendations is whenever it's possible to do so, try to do both of these things in the same statement. Right, so here's an example of a statement that is both declaring a variable. The left-hand side basically says OZS is an integer variable. And at the same time, along with declaring it, it's also giving it a value. It's basically doing a computation and using the result of that computation to assign a value to the variable. And my recommendation is to do this whenever it's possible to do so. Another part of this recommendation is that you should be doing this sort of thing where you declare the variable and you initialize it right before you intend to use that variable for the first time. Right, so when you're writing your program, in the course of writing a program, you're going to be using many different variables, but you're going to be using these variables at different points in the program. And my advice is, in each case where you plan to use a variable, wait until just right before you start using it to do this step. If you put the variable declaration and the initialization as close as possible to the first place in your program where you actually use that variable, that will help guarantee that you get all of these details right. All right, so that's sort of general advice on how to handle variables and how to avoid those very common and easy to avoid variable problems. All right, now next, let's talk about curly braces. After simple problems involving variables, the next most common problem that I see, and this is an even much more frustrating problem when you run into it, is problems involving curly braces. And the issue here gets to be quite a bit more frustrating because in some cases, if you leave off a curly brace, what that can do is that can generate a cascade of errors where 50,000 things in your program start being underlined, and you have no clue why all of a sudden all of these dozens of things have underlines under them. Right? Well, whenever you see vast numbers of red underlines popping up, the cause in every case is almost a missing curly brace somewhere. This wreaks the most havoc in Java. If you forget a curly brace in some location, it messes up all kinds of stuff. Not just in the place where you left out the curly brace, but often through the rest of your program all the way down to the bottom. Okay, and since missing curly braces are a very common source of very frustrating errors, let me now give you some advice about how to avoid the missing curly brace problem. My first and biggest piece of advice related to curly braces is that when you are getting ready to do something in Java that requires curly braces, type the curly braces first before you do anything else, right? And the classic example of this is an if statement, right? So suppose you're writing a program and you're going along and you decide, okay, I need an if statement here. As soon as you decide that you need an if statement, my recommendation is that you start by typing this. This is basically the skeleton of the structure of the if statement. and it has all of the key parts in it already. Most importantly, it has the curly braces that are necessary. You've got these curly braces for the if part. You've got these curly braces for the else part. And if you type them right away at the very start, at the beginning of making your if statement, that will guarantee that the curly braces are in place and you won't accidentally make the, oh, I forgot to type a curly brace problem. All right, then after you have this structure in place, you can go in and fill in the various parts. You can go into the test and write the test. Then you can go into the if part and write the logic that goes there. And you can go into the else part and write the logic that goes there. All right, so there's nothing that says you have to type an if statement in order from left to right, because very often when I see people do that, what happens is they get into the weeds somewhere partway through typing the if statement, and they sort of they focus on what goes into the if statement too much, and they forget simple little details like the curly braces. Right, so the obvious advice for how to avoid the curly brace problem in this case is type them first. In fact, what you might just try doing is, since this is going to show up in the lecture notes on the course website, you might want to bookmark that page so that anytime you have to do an if statement, you simply go to the page and copy this chunk of code and paste it into your program. That will guarantee that you have the right structure of the if statement right from the very start, and that will go a long way toward preventing the missing curly brace problem. Okay, and you can follow the same advice in every other instance in Java where you need curly braces. This includes things like loops. If you're setting up a while loop, put in the curly braces right away. If you're doing a for loop, put in the curly braces right away. If you're writing a method, make sure that you put a left curly brace at the top of the method and a right curly brace at the end of the method before you put anything else in the method. If you get in the habit of always putting in the curly braces first, that will go a very long way to avoiding this very annoying missing curly brace problem. All right, so that's my main advice related to curly braces. Okay, now here's another topic that still is confusing for many people, and that is how to construct this very specialized if statement. This is an example of what's called a chained if-else statement. And it's basically a whole series of if statements that are glued together in a specific sequence in a situation where you need to ask several questions in order to completely resolve some issue and figure out what to do. All right, and I brought along an example that should be familiar to you. This is an example that comes straight from lab number 3. Because in lab number 3, one of the problems we had to solve is when we get to a particular day in the month, how should we be printing that day? And there were 4 cases you had to think about. One is that if the day number is less than 1, you need to print spaces and no number. The second is that if the day number is less than 10, you need to print extra spaces along with a number. The third case is if it's a normal date with 2 digits, but it falls within the month. In that case, you need to print just a single space plus the date. And the final case is that the date number may have run past the end of the month. In that case, you need to go back once again to printing only spaces. All right, so here's an example of a situation involving a variable, and the value of that variable can put you into one of 4 different cases. And again, the appropriate construct for making those sorts of decisions is this chained if-else construct. Okay, now again, a lot of you are still sort of getting used to writing these sorts of things. And again, this is one of the more complex things you can do with an if statement. So let me now give you some pointers about how to approach this and how to set this up. Okay, again, my first piece of advice is watch out for the curly braces. Get in the habit of putting the curly braces in. And the general rule for this sort of structure is that after each test and after each if, you need a set of curly braces. All right, so here's one set after that if. There's another set after the next if. There's another set after the next if. And at the very end of the structure, the last thing you'll see is an else with a final set of curly braces. All right, and then the other thing you need to think about for a structure like this is what tests you should be using. The purpose of these tests is to put us into one of several different categories. And you decide which category you're in by asking a series of questions. The first question here is the date less than 1? And if the answer to that question is yes, I know exactly which category I should be in, so I can go ahead and write the logic for that category. Then the next question after that is the date less than 10? And we have a category for that. Next question after that is the date less than or equal to the days in the month? We have a category for that. And finally, at the end, there is always a catch-all category. This is meant to catch any of the cases that were not caught by the previous questions, and it's the last possibility to do something. All right, and finally, the last thing to point out about this structure is that the order of the questions matters. If you get the questions in the wrong sequence, it messes up the logic. For example, if I had asked this question as the first question, is the date less than or equal to the days of the month? Well, if I put that test as my first test, that would catch every date that falls before the end of the month, but the problem is that covers multiple categories. That covers the negative dates, it covers the dates less than 10, it also covers the dates that are normal dates. All right, and this is a mistake that you can make if you put the wrong test at the wrong place in this structure. That test can actually end up catching multiple categories at the same time, and that will mess up your logic and will cause this thing not to work correctly. All right, so you do have to pay close attention to the correct ordering of the questions, and in cases like this where there's an obvious numerical sequence involved, the obvious way to organize the questions is from left to right, going across the sequence of numbers. All right, so the first numbers are these, the next numbers are these, the next numbers are these, and again, the catch-all catches everybody that comes after the end of the month. There's a logical sequence to the numbers, and that leads to a logical sequence of the questions here. Okay, so again, this is sufficiently important that I thought I should review it, because again, this is a construct that many people are still struggling with, and this is a skill that everybody is eventually going to have to master, is the skill of putting together a chained if-else statement. Okay, now does anybody have any questions about either this example or more generally what goes on with chained if-else statements? Okay, now the last set of things I want to talk about, because the exam will cover methods, there's a whole host of issues related to working with methods, and all of these are potentials for trouble and they're potentials for mistakes. And rather than just read this slide to you, what I'm actually going to do is I'm going to pull up one of the examples that I showed earlier in the lecture. Let's look at an example that has a number of methods in it and see, again, some of the considerations that come into play when you are working with methods of some sort. All right, so let's go. Let's see, actually some of the array examples had lots and lots of methods in them. Let's, for example, look at the merge sort project. That had a lot of examples of methods going on. All right, so let me pull up, all right, so here's a typical example of a thing that has several methods involved. Okay, now, the first issue always when you're writing a program involving a methods is discovering the fact that you need that method in the first place. Right? And usually the way this will work is you're going to start working on some moderately complex problem, and you are going to realize along the way that this problem naturally subdivides into fairly obvious parts. All right, so here's a typical example. This is, again, the example that is trying to find the number that shows up most often in a particular list. And when you sit down to start writing this program, the first thing you'll realize is that you'll need to actually read these numbers from a file. Right now, you could approach that in one of two ways. You could simply type in the code to read the numbers and put that all here in main, or you could say, hey, why don't I use a method to do this work for me? Why don't I imagine a method that will do the work of opening up the file, reading the numbers, putting them in an array, and giving that array back to me. All right, so that's the first step in the process of using methods, and that is simply discovering the fact that you need a certain method. Right, so here I've discovered that, hey, it would be really handy if I had a method that would solve the problem of just reading the numbers from the file. Okay, so that begins the process of constructing a method. I have in mind the need for a method. I have in mind what I want this method to do, and along with an understanding of what I want the method to do, I can very quickly come up with a name for it. All right, and this is always the first thing you should think about when you're putting together a method is what is a reasonable name for the method that describes the purpose of the method and what it's actually doing. All right, then along with imagining how this method is going to work, you should also think about what this method will do, and you need to ask yourself a couple of questions. The next question you need to ask yourself is, will this method need any information to do its work? All right, in this case, a useful piece of information that the method might want to make use of is the name of the file it should be reading these numbers from. All right, and again, every example is going to be different. Every method is going to require slightly different information to do its work. And in each individual case, you need to think about what the method is doing and ask yourself, what information will the method need to do its work? All right, so in this case, I've decided that the only thing this method will need is just the name of the file to work with. And then finally, along with thinking about what you want this method to do, you need to ask yourself, will this method be returning any information to me? And if so, what is that information? Again, in this example, the method that I'm imagining is a method to read a bunch of numbers from a file. What that method will do is it will read the numbers, it will put the numbers in an array, and it will give me that array as a result. Right? So in fact, in getting ready to use this, I would write some code that would call the method and then immediately assign the result to an array variable. All right, so that's the other thing we discovered that this method needs to return an array of numbers as its result. Okay, so all of that is work that you need to do when you first imagine wanting to use a method. You need to sort of come up with a short description of what the method will do. You'll need to come up with a name for it. You'll need to figure out if it needs any inputs or parameters, and you'll need to figure out what that method is going to return. All right, these are all questions you need to nail down when you first imagine using a method in your code. All right, then next you transition to actually writing the method. All right, so at some appropriate place in your code, you set aside some space for the method, and you start typing out the details of the method. All right, so the public static part, that's automatic, that's always going to be there. This part is the return type, and we've already answered that question because we've already figured out that the purpose of this method is to return an array of numbers to us. In this case, it's going to be an array of integers. All right, then of course we've decided on a name for the method, and we've decided that the method needs one input to help it do its work. It needs to be told the name of the file. All right, and that's going to force us to have a single parameter, which is a string, that brings in the name of the file so we can open the correct file. All right, and then finally, my last piece of advice when you get done typing this first line of the method is don't forget the curly braces. So put in the curly braces right away. Put in the left curly brace here, and a couple of lines below it, put the matching right curly brace so you have those in place already and you don't end up forgetting them later on in the process. Okay, and then what comes next is writing the actual code of the method. At this point, you should have some sense of what you want the method to do, and you should then sit down and carry out the task of doing the work of the method. In this case, we're using some fairly standard code to open up a scanner, count how many numbers are in the file, make an array, read the numbers, put them in the file, and then return the array. Individually, these are all sort of well-known tasks, and if you put all these tasks together in the right sequence, you have everything that the array is meant to do. All right, and finally, the last two things to check when you're writing a method are, did I use the parameter in the correct way? Did I make use of this at some point? And at the other end, did I have a return statement? Because again, if the method's going to return something you're absolutely going to need is usually at the very end of the method, you'll need to have a statement that returns that thing. right? And as far as the parameter goes, you always need to check and make sure the parameter is actually being used. In this case, since it's the name of the file, we actually have to use the name of the file as part of the process of setting up the scanner that reads from the file. So that guarantees that that parameter is actually being used for something. Okay, so it's a whole lot of stuff you have to think about when you're putting together a method. And again, this is an ongoing process. I'm sure not everybody is entirely comfortable with this process right now, but over the remainder of the term, as we go through many examples of using methods, you all are going to get much more skilled at doing this. And the hope is by the end of the term, all of you will be able to do all of these steps in your sleep. You'll be able to recognize when it's time to write a method. You'll be able to sketch out the structure of the method, and then you'll be able to successfully go through the steps of setting up the method. Right? And again, this is going to be a process. It's going to take us until probably the end of the term for everybody to get comfortable with this. But this is one of the key skills in this course that everybody will have to master. Okay, any questions related to this method example here, or anything more generally about methods that you'd like to hear me talk about? Okay, and more broadly, is there any other topic, anything we've covered through the first 6 chapters of the course that you would like me to say a few more words about right now, because we do have a few minutes left here at the end of the lecture today. Okay, well, if not, let's go ahead and call it a day. We're gonna finish early today, and then when we come back on Monday, what I'm going to be doing is I'm going to be moving on to Chapter 8. Chapter 8 also deals with arrays, so there's going to be more discussion of arrays, and then of course the lab next week will be the first of 2 labs connected to the topic of arrays. All right, and in the meantime, don't forget that I have posted a programming exercise for this week. This is an arrays exercise, and as usual, that will be due on Tuesday of next week. All right, so with that, I'll wish everyone a good weekend. Start getting ready for the midterm and work on the homework. And other than that, try to have yourself a good weekend. So long, everybody.
Thank you.